Hey guys, today in this video we're going to just talk about how to distribute a radical and simplify expressions that involve distributing with radicals. The nice thing is that distributing is just the same as you've done in the past. It's all about just being able to simplify the radicals, remembering how to multiply, and how to add and subtract radicals. So it's about knowing when to use which properties and when to combine like terms and such. So our first one we're going to look at, we have root 2 times the quantity 4 times root 3 plus root 6. Now I usually do is whenever I have something in parentheses, I like to see if I can simplify and combine like terms. It'll make things easier, but we can't simplify in here, so we just need to go ahead and distribute like we normally would. So we're going to multiply everything by root 2. So you're going to end up with 4 times, and if you don't remember, it'd be like 4 times root 3 times root 2 plus 6 times root 2. When you're multiplying, you can root 3 times root 2 would be root 3 times 2 like this. So you end up with 4 root 6. And root 6 times root 2 would be root 6 times root 2 under the same radical sign. But you could break that up, and root 6 times root 2, you could either multiply it out and then simplify, or you could say it's root 3 times 2 times 2, in which case either way you're going to end up with a 2 root 3 in the end. So this would be simplest radical form. We can't combine any like terms there, and we can't simplify the radicals. So that was our first. Our second one, let's make some space. We have root 5 times the quantity of 6 plus root 10. So let's go ahead and distribute. We're going to have 6 root 5. Can't do anything there, so we're stuck. But we're going to have root 10 times root 5. This is going to be, you can either put them both under the same radical, or you can just multiply them together. So you could say 10 times 5 under the radical. I'll just go the route of saying it's root 50. That's the 10 times 5. And then you can break that up. So you'll break this up into 25 times 2, which means you're going to end up with 6 root 5 plus 5 root 2. Can't combine any like terms down here. Radicals are simplified, so simplest radical form right there. Let's do a couple that are maybe a little more difficult, and then we'll see how we can use foiling with radicals as well. Just change colors. So our next one, we have 4 root 15 times the quantity, root 6 minus 2 root 5. So we're going to go through the same process. We're going to distribute. So we're going to have 4 times, and I'm just going to write it like this. Since we multiply these together, it's going to be 15 times 6 under the same radical. 4 times the 2 is going to get you an 8. And then under the same radical, you'll have 15 times 5. What I'm doing for that second one, I'm not showing my work for it, but we're multiplying these two together, multiply the two coefficients, and then underneath the radical you can use our property, our square root multiplication property. So over here you could multiply it out and then try to simplify. I'm just going to break it up. 15 is 5 times 3, 6 is 3 times 2. So you're going to have a 3 squared in there, so you can go ahead and take the square root of that, bring it out. You'll end up with 12 on the outside, and then 5 times 2 is 10. So 12 root 10. Over here, I'll do the same thing. I'll break it up. 15 is 3 times 5 times 5, so you'll have 5 times 5, which is 25. You take the square root, so you're going to bring a 5 out. 8 times 5 is 40, and then you'll have a root 3 left over. And that would be simplest radical form. Radicals are simplified, and we can't combine them. They don't have the same radicand. Alright, so that was our third one. On to our fourth. Our fourth one looks like this. We have 2 root 12 times 7 minus 3 root 3, and then minus square root of 3. I notice here that I can simplify, so I'm going to simplify before I go ahead and multiply. So 2 times, well, 12 is going to be 4 times 3, so you can take a 2 out. It'll be 2 times 2, so you end up with a 4 on the outside. And then root 3 on the inside, or 3 on the inside. And then minus 3 root 3, minus root 3 on the outside. So if we go ahead and distribute, so we're not going to be distributing to this negative root 3 here. 4 root 3 times 7, well, that's just going to be 28 root 3. There's no radical here. And then we're going to have 4 times negative 3 root, or 4 root 3 times negative 3 root 3, and we'll end up actually with this being negative 36. I'll show you how that works out. 4 root 3 times negative 3 root 3. You'd multiply the 4, and the negative 3 is negative 12. And then root 3 times root 3, well, square root of 3 times the square root of 3 is 3. So negative 12 times 3, that's where the negative 36 comes from. And then we have a minus root 3 here at the end. So we're not in simplest radical form because we can combine these like terms. So 28 root 3 minus root 3, we should end up with 27 root 3, and then minus 36. And the 36 is not in the radical. So that is simplest radical form for this one. Again, it's all about remembering the rules for multiplying, remembering how to simplify, and then trying to find like terms that you can combine together. So our last two involve foiling now. So we have 7 plus root 6 times 1 plus root 6. So we're multiplying two binomials together. If we could simplify inside, we would, but we can't. So let's go ahead and multiply. 7 times 1 is 7. 7 times root 6 is 7 root 6. That was our first, our outer. Now our inner, root 6 times 1 is plus root 6. Root 6 times root 6 is going to be a positive 6. So now we just need to combine some like terms. So we'll have 13 plus 8 root 6. Can't simplify our radical, and we clearly can't combine any like terms, so we're in simplest radical form like this. Alright, our last one of the slides. We have 4 minus 5 root 10. That binomial is being multiplied by the binomial root 5 plus root 2. So let's go ahead and multiply the 4 by both terms. You'll have 4 root 5, and then plus 4 root 2 when you multiply. Then we're going to go ahead and multiply here. We could simplify first. You don't necessarily have to. If you wanted to simplify first, this 5 root 10, actually you can't simplify that, so never mind. Let's multiply through. So negative 5 root 10 times root 5. We're going to have negative 5, and I'll write it out like this. You're going to have 10 times 5 underneath the radical, and then negative 5 root 10, so we're going to have a minus here, times root 2, you're going to have minus 5, and then root 10 times 2. And you can either multiply these and then look for perfect squares, or just do the prime factorization of them. So let's rewrite what we have in the front here. Nothing we can do with these yet. This one I'll say is root 50, and root 50 ends up being 5 root 2. So when we do that, you'll end up with minus 25 root 2. So simplifying the root 50, you get down here, but you have to multiply that by that 5 in the front. Over here, let's say it was root 20. Root 20 would be 2 root 5. But you're going to have to multiply by that 5, so you're going to have minus 10 root 5. And now we're just looking for like terms. So for root 5, there is another root 5, it's minus 10. So you have minus 6 root 5. And for root 2, you have minus 25 root 2, so you have minus 21 root 2. And you are all done. Can't combine like terms. Both terms are completely simplified, so we're in simplest radical form here. So these are all about just remembering the rules, how to use them, and making sure that you're doing them correctly and not confusing them. Let's go ahead and try some of these on your own with distributing, and have a nice day.